Hello, everyone. Can you see my screen? That's a joke, you know. Okay, so first of all, I would like to say that I'm really happy to be here. This is the first time that I come to Argentina, and I just want to, I don't know, try those alfajores and try the asado. So really excited to be here and know more about your culture, and let's see how it goes. Also, really happy to share some of the work that me and some other Airbnb engineers have been working for the last couple of years. Okay, so let's take a look at the agenda. So first of all, I'm going to talk about myself, some of the experience that I have. Then we are going to talk about, okay, I know this is another strings talk, right? I know we already talked about that, but we're super passionate about localization strings, so why not doing another one? So maybe we will go through the Apple APIs a little bit quickly because we already saw that. And then we're going to take a look at some localization optimizations. What can we do to those files to reduce app size? And finally, we're going to see how those optimizations are applied inside the Airbnb app. So my name is Miguel Jimenez. I'm originally from Guadalajara, Jalisco, Mexico. I've been an iOS engineer for 6 years, and you can follow me on Twitter. That's my Twitter handle. I don't really post a lot of stuff, but my DMs are always open. If you want to reach out and chat about anything, just feel free to do it. So before joining Airbnb, I was mainly working on startup companies, and I never worked on an app as big as Airbnb. So the challenges that we had are really different, and also the focus. So my focus working on those companies was like building features faster, like having nice animations and all of that. So those are different challenges. So I was not going to focus that much on performance because I had to release like the features as soon as possible. Eventually, in February of 2020, I ended up joining Airbnb. I moved to San Francisco, and I was thinking, oh man, I'm going to move from from Mexico to San Francisco. That's going to be a life-changing experience. So yeah, it was, because 1 month after I moved, COVID happened, so it changed my life totally, definitely changed. So inside Airbnb, I'm working right now on this team. It's the client foundation team. This is a really cool one because we kind of focus on app quality metrics, or so for app quality metrics, I mean app size, startup time, page performance, and so many other ones. So I don't know, I kind of like that because instead of working on a product team, I can work on these other optimizations in these other areas of the app that are really important, and that when I was working on startup companies and smaller apps, I never had the chance to do that. So that was pretty cool. Also, you might believe, like, the user experience, we always try to deliver the best user experience. And obviously that kind of comes with animation, like having this view that flows from the left to the right, flipping around and all of that. And yeah, that's a pretty nice user experience, but also there are some other, like, app quality metrics also affect the user experience, all the way from when the users go to the App Store and they download your app, all the time that they wait, and then when they launch it, all the time that they have to wait for it to launch, and obviously, like, the page performance, right? How soon the page is rendered, and it starts showing meaningful information to our users. So all of that really represent what a really user experience is. And in this team, I have the chance to work on a little bit of that. So now let's review. Let's go quickly through that. I didn't know there was another localization strings files, but just go right into that. Files hierarchy, we already reviewed that. Just let's highlight something important about the Airbnb localization files. If we take a look at this single language is 1.1 megabytes. So that's kind of huge. The format, we already reviewed that earlier today. It's a set of key value pairs. The API usages, for UIKit, we would use NS localized string. We already saw that. For Swift UI, we would use something called localized string key that we also reviewed earlier. So let's just skip through that. And let's review some takeaways about how localization APIs work. So all the strings files are downloaded when the users download your app. So every single them. So if you support 10 languages, all those files are going to be downloaded. Then those files are open and at runtime. So whenever the user opens the app, The OS is going to look at the preferred language of that user, and that's the a specific localization file that is going to open. So let's keep that in mind. So these APIs are pretty good, right? They work nicely, and why do we want to do something about that? What is the challenge that Airbnb sees when dealing with these APIs? And the main challenge for us is app size. So, and we're going to see why that is the case. Okay, so for Airbnb specifically, we support 61 languages. Those are a lot of languages. And in 2019, we ended up adding 31, and that's how we ended up with 61. If we don't do any optimizations whatsoever to our localization strings files, they are going to take around 54 megabytes of app size. So that's a huge, huge amount. And that's something that we want to prevent. So here we have Susan representing everyone. I don't like apps that are big. Yeah, I can see that, Susan. I don't like them either. So there is a direct correlation between app size and app installs. So the bigger your app is, the less likely users are going to install it. And if they already install it and they run out of space, it's the most likely they will uninstall your app. So that's the reason why we have to focus on app size. So now let's take a look at those optimizations. Like, what can we do to improve the size? There are two optimizations that we applied and that we're going to review. The first one is compressing strings files. And that's kind of a pretty obvious one. So what are we talking about with strings compression? So typically, a user only uses a single language on an app. So when I'm on my phone, it's going to be either in English and Spanish, and I don't constantly go like, let me see how it looks in Chinese. That's just something like users don't really do. And so there is an issue, right? We have all those localization files for every single language that are installed or that are downloaded with the app, and they are never used. They are infrequently used. And the idea is that we can compress all those files, all those files that most likely we are not going to use, and then we're going to decompress them at runtime. So when we compress them and we ship the app to the store, they are taking less space, improving download and install size. And we do that using an algorithm that comes from Apple, and is shipped with the OSs, iOS and macOS, and is LCFCE. So this is basically the idea. So when you're building your app, you're going to take the standard localization strings files that you already have. You're going to feed that into the algorithm, compressing algorithm, and that's going to spit out the compressed data. That happens at build time. And then at runtime, you're going to take the compressed files, feed that into the algorithm, and you're going to uncompress, and you're going to get the uncompressed data. So the trick here is to only open and only uncompress the user's current language, the file associated to the current user's language. And pretty much that's the idea. It's pretty simple, and we're going to see how that is implemented later on. The second optimization is the duplication of localization keys. Let's see what am I talking about. So here we have an example. We have two strings files, one for Spanish and another one for English. So we have this, the keys, my app's reservation details key that translates to detalles de reserva, and room price key that translates to precio de habitación, and the same in English. So if we take a look at this, there is something weird. There is some duplication here. And where is the duplication coming from? Exactly from the keys. The keys have to be included every single time in every single language. And we can see that this problem scales linearly the more languages that you support. So if you add another language, let's say German, you're going to get, again, the keys. And the more translation that you add, those keys that are added also keep duplicating across every single localization file. So the idea of the duplication is taking this format and converting the format into this new one. So in this new format, now instead of having two files, we have three files. And let's review them one by one. On the first one, we have the English version, but this is an array, and it only has the actual translation. If we take a look at the second one, we have the English version, and it's only the translation. And on the third one, we have a global list of keys where the keys appear only once across our app. So we remove the duplication on this new format. And if we pay a lot of attention and we take a look at the first item, they have to be aligned. So the order on this format is super critical and important because we can consider the first element of this array is going to represent the reservation detail translation in every single language. So the order must be the same in every single file. So the idea is that after we get this new format that is totally different to what Apple provides, we can zip the specific language that we're working on with the global list of keys. We're going to zip that together and get back the same format that we had previously. And that's going to happen at runtime, and that's how we are going to end up recreating the original dictionary. So that's pretty much the idea. And what are the trade-offs? Everything is about finding balance in our app, right? So we have some meaningful trade-offs, and let's review them. So the first one, the pros for us, is reduced app size. So that's pretty good. That's what we were looking for. We wanted to reduce app size, and that's what we're getting. Perfect. The second one is that we have to create a custom strings pipeline for this to work. It has to be something totally custom, and that gives us a lot of flexibility. Because in the future, if we want to perform another optimization, we can do it because we have full control on the pipeline. An idea of this, let's say we have multiple translations happening on the app, and you can imagine like a next button, like the title next, could be repeated multiple times using different keys. So we could be able to identify all those duplicates and remove them automatically, and by doing that, we are going to further reduce the app size. So what are the cons of this approach? The first con is that it doesn't really work with Apple APIs, the NS-localized string and localized string key from SwiftUI. And the reason why this doesn't work is because those APIs require localization.strings file. So we won't have any file with that file extension, and therefore won't be able to find any of the localizations that we are bundling with the app. And the second one is kind of similar as the pros, but you need to come up with a custom solution. The problem with a custom solution is that you have to build it, test it, maintain it, make sure it is stable, and this is a really critical part of your app. Just imagine what's going to happen to your app if localization is messed up. A user is not going to see anything, or could be looking at a different language, or if translations are mixed, the context doesn't going to make any sense, so that's a really huge pro. So I don't think every single app should be adopting this. If you're doing that, you should make sure that the pros outweigh the cons for this specific approach. For us, it does, and that's the reason why we work on them. And how is Airbnb implementing all of this? So we have a two-phase implementation, one that happens at build time and another one that happens at runtime. Let's take a look at the build time first. So this is the build pipeline. We're building the app normally, like grabbing all source files, linking them together, and all resources as well. And we end up with this Airbnb.app that contains all the localization strings files. This is the original format. We don't want to mess with how people are updating and adding strings to these files. We want to maintain, we don't want to be disruptive in that process. So then we run our deduplication and compression algorithm. So pretty much we take the localization resources, we open every single file, we decode the content, and now we have like arrays and dictionaries. We then we convert that into data, we compress the data, then we move this new format after the deduplication and decompression to the bundle again, to the app bundle, and finally we remove the original files. That's super important, otherwise you are not removing app size. So at the end, you end up with this Airbnb.app that contains all the new files, the new format, all the localization files that are compressed, and the global list of keys. So let's review the compression step. This is interesting. So we are using this compress method on NS data. It's pretty simple to use. You just use it you have some data, like this original data. We kind of map that to an NS data and access the method directly, and we just provide the algorithm that we want. In this case, is LCFC that we were talking about earlier. So this is happening at build time, so this is not something that is going to run on the app, because that's outside the app. It's actually run by the machine that is building the app. And something nice about these optimizations is that those are built using a Swift CLI tool. So we are technically, it's a command line tool written in Swift, and everyone that knows how to write Swift code, they can contribute to this type of optimization. So that's pretty cool. Now let's review the second phase of the optimization, which is something that happens at runtime. So when the app is launching, we have all the resources that we already reviewed, the new compression files and the keys file and all of that. So we launch the app, we have main, we have the finish launching with options, and then we have this strange class, string manager. This is a custom class, and that's what is replacing the Apple APIs. Let's see what it looks like. So before we look into that, there are some two key pieces of code that I want to highlight and that pretty much makes all of this work. The first one is selecting the current user language. So you can access that through bundle, main, prefer localizations. That's pretty much what Apple does under the hood. And to open that specific localization file, you use bundle, main, path for resource. You provide the name of the resource, the type of the file extension, and you provide the language ID, which you got from the bundle. And pretty much that's all you need, and you have access to the right localization file. So this is the setup that a string manager does. So we have an optimization. We don't really want to slow down startup time because we're going to be doing some decompression steps. So that takes time. What can we do to optimize that? So we save a decompressed version of the translations for the existing language. So on the first run, during the first app launch, we won't have anything to rely on, so we would do just the process. So what is the process? Opening the keys, opening the translations, obviously decompressing the data, then zipping all the data together, transforming that into a dictionary where the keys are actually the translation keys, and the values are going to be the actual translation values. And at the end, we keep a representation of this state in memory. And we're going to see a sample of how this looks in code. After that, we're going to save that representation, that dictionary, in a file, and we're going to append the app version and the language that we use to generate this file. And we do this, so the next time we get a subsequent launch, we are going to use this file instead, so we don't go through the whole decompression steps. And that's going to maintain startup time as it was before. So also, if a user changes languages, obviously this file is not going to be valid anymore, so we need to regenerate that. So we use pretty much the name on the file to detect it is invalid and regenerate the file again. And the same happens when a user updates the app. If the app version changes, we will do that as well. So this is a kind of a representation of our string manager file. And then, let's see. So we would go through the process. We gotta, if the cache file exists, we will load it. If not, we will load the current language. And at the end, we're gonna save all of that into cache. Then we're gonna save everything in this translations dictionary. That's what I was telling you. And this is gonna be a singleton. This string manager is a singleton that lives through the whole app lifecycle. And yeah, I know we were discussing singletons a little bit before, but we have some whitelisted dependencies that on Airbnb we can access through singletons, and this is one of those. At the end, we have this global function translation that we use to access those translations. And yeah, pretty much that's it. This is a kind of a representation on how it works under the hood. And for developers, instead of using NS localized string, they are going to use this translation with key API that is pretty much calling the function and the singleton under the hood. So the experience is pretty much to the one that we currently have. So let's talk about the impact. So the impact, before any optimizations, strings files represent 22% of the total app size. That's a lot. If we apply compression, we drop that to 8%. We can see like how the yellow section is decreasing. And finally, after applying keys deduplication, we drop that even further to 4%. And pretty much that's the optimization. So we can say that 4% that end up being the result is way better than the original 22. And that's a total 82% reduction on our localization resources. So that would be a huge win for us. And then we provide launch time impact. For this, we use Emerge. Emerge is, they have a booth outside. It's a company that we work with, and they help us to validate app size. You can reach out to them, and they can provide you additional details. And then also, we went through a set of validation steps to make sure everything was working as expected. First of all, a lot of unit testing. A lot of unit testing to make sure everything is going to work as expected. Then measuring impact using instruments, using Emerge for both app size and startup time. Running those optimizations on alpha, beta before releasing. Notifying QA teams to test this out. After everything went successfully, when we notice any issues, we just launch it to the App Store. At the end, those optimizations have been released for quite some time. The first one, the duplication, no, I'm sorry, the compression step was launched in 2019. The duplication was launched on May this year, and they've been working perfectly. So as a summary, we saw how compression can help us to alleviate the app size of those unfrequently used localization files. Then we see can do the duplication can remove these redundant data on our strings files. Finally, we saw like how Airbnb uses an export and build pipeline to reformat the original files. And finally, how at Runtime, we are working with the new format to provide localizations to all the app. And Emerge also, this company that I was telling you that we work with, actually they came up with this idea, and they have a sample implementation in this GitHub repo. Feel free to take a look. Also, feel free to follow them on Twitter. They post really nice stuff. And I guess that's it. Thank you.
Thank you for the talk, Miguel. We have some questions, and as in the previous, we will use the previous format. Top 3 most voted questions will be the ones. So, our first one, how do you handle plural string without Apple String API?
Oh, yeah, that's a pretty good question. So actually, Airbnb doesn't use Apple Pluralist API. We have a custom one. And yeah, to be honest, that is not handled by this optimization that I was talking about. But yeah, we use something totally custom because it doesn't work with plurals from Apple.
OK. Luis asked, since you're already using a custom localization implementation, why not just skip the files from the install and only download the one you need on demand?
Oh, yeah, that's also a pretty good question. And that's something that we reviewed at Airbnb. There were some ideas, and obviously that came out. So technically, that would hurt startup time, right? Because when we launch the app, we won't have the localization available. So we are introducing an additional delay, and that depends on the network connection. And if by any chance this would fail, like the experience would be really bad. So we ended up not implementing that because of all the complexity that it had and the potential pitfalls.
OK. And the last one, if you have a very creative UX team and decide to change a single word, should you generate a new version, or how do they handle it?
OK, so if a designer, if we have the translations and they update again the strings files, so as I mentioned, we would perform this format each time we build the app. So whenever we are going to release, that's when all the format is going to be recreated. So that doesn't really affect this optimization.
OK. Thank you, Miguel.
Thank you.